Hello there. We have this amazing piston drawing that we would like to add form tolerances to. And the first step in adding tolerances to a drawing is to define the functional surfaces. We have to understand the function of the part. So we have to ask ourselves one question is what, where is this part going to have contact? So contact is the keyword here with other parts. And also we have to know the function of the part in general. We know the function of a piston is it is inside cylinder, an engine cylinder. We have an air-fuel mixture here that gets a spark from the spark plug, and it explodes. And this explosion forces the piston to go down because that's the only where to go. Because we have here the walls of the engine cylinder. And we also have a piston, a connection rod that is, let's actually look at another view. Here, if we look at this view, we will have a connecting rod mounted here via a pin. So a pin will be inserted here, yeah, to be like that. And then here we have the connecting rod. All right, so that's the function of the piston and where it will be mounted. So we have this surface here, this cylindrical surface or cylindrical feature. This is a functional surface. We have that surface here on top that gets the explosion of air. That is a functional surface. And if we look at the other views where the connecting rod is mounted inside, we have, let's actually delete this, and we have this surface in which the pin will be mounted. This is also functional surface. And here where we have a connection with the connecting rod or the contact with the connecting rod, this is a functional surface. So the cylinder, the flat surface on top, the two holes, and this hollow feature. Here's the cylinder, and here is the flat surface. All right, so now we defined the functional surfaces. Second step is to know which tolerances you could possibly use for each functional surface. So if we have the cylinder here, this is a cylinder, right? We cannot add flatness to a cylinder. We cannot add straightness to the outer surface. Well, theoretically good, but wouldn't make any sense. But you could add the straightness to the center line of the cylinder, and you could add circularity, and you could add cylindricity. And then we have here this surface. It's a flat surface, so we could add straightness and we could add flatness. And then we have the two holes. And for the two holes, these are cylinders, so we could add cylindricity, we could add circularity, and we could also use straightness of the center line. And then we have this surface, or these two surfaces, for which we could add flatness, because it's a flat surface, and we could theoretically add straightness. Yeah. All right. So let's have a look at the cylinder and choose which of these tolerances, or we could also add all of them, but which makes sense to add. All right. So for the cylinder, I would go with cylindricity. And the reason I choose cylindricity over circularity is that I have a big height here. So if the cylinder height was too small, of course this is relative, but relative to the size of the whole part, here we have more than half of the whole height is the cylinder, so it's definitely a cylindricity here. But if we only had 2-3 millimeters of cylindrical surface, then in that case you could go for circularity. And the reason is, if you have only 2 millimeters, there's actually not much place to measure at different cross sections. It wouldn't make sense to use cylindricity for such a small height. Again, there's no right and wrong. If you still use cylindricity for such a small height, for 2-3 millimeters, it is correct, but you'll probably get a call from your measurement technician saying, do you really need that? Or can I use circularity for that? Then they would just use one cross section, and that would be circularity. All right, so I would go for cylindricity here. Straightness of the center line. Whenever I use cylindricity, I would give up the use of the straightness of the center line, because straightness of the center line is covered in cylindricity, right? If you have a cylinder which is cylindrical, its center line would be straight. You could add, uh, you could still add the straightness of the center line if in case you want more precision for the center line. But in that case here, we actually care that the cylinder is cylindrical, and that's what we care about. So in that case, I would actually only go for cylindricity for that cylinder. For the upper surface, I don't need the straightness of a certain line because it's actually just a surface. There's no edges. I don't need a certain line to be straight. I only need the surface to be flat, right? You don't want it to be wavy so that it creates lateral forces. Yeah, and if it's wavy like that, and then you have the explosion, and then you have smaller forces pushing in all these directions, then you would have lateral forces on the cylinder um, walls, and you don't want that. You want it to be as flat as possible to take all the force down where it's supposed to go, to the crankshaft. So I would use flatness for that surface. And then we have the two holes. Let's actually draw the center line. It's not drawn here in the drawing, which is bad, but now we have it. So for these two holes, circularities. Again, there is a lot of surface here to use circularity, so I wouldn't use circularity. I would rather go for cylindricity. And then straightness of the center line as an exercise to these holes. All right, and then we have these two flat surfaces. I would use flatness for them. There's no sense in adding straightness of a line while these surfaces don't have any distinct lines that somehow are especially um, important for the function. The whole surface is important for the function because it has contact with the connecting rod. All right. So here comes the exciting part. How do we add these tolerances correctly to the drawing? let's go with cylindricity. We want cylindricity of a surface, of a cylindrical surface. Cylindricity cannot be of a center line. So we have to point at the cylinder itself that we want to tolerate. So let's use another view. Could of course use this view, but just for the ease of visualization, we will have to put it here. I will put it directly to the cylinder. So what do we need? We need a feature control frame of 2 parts. In the first part, we add the value of the tolerance. We add which tolerance we would like to control, so the characteristic. And in the second block, we put the value of the tolerance zone. We will now use exemplary values because we are not doing any tolerance calculations. We don't have information about what is actually a good value or a correct value here. All right, so that's how we add cylindricity tolerance to a cylinder. We don't need a diameter sign here. It would be a mistake to add it because what does this 0.1 mean? It means that we will have 2 cylinders, a bigger one than our cylinder and a smaller one than our cylinder, and the distance between those will be 0.1. So it's a distance, it's not a diameter. We are not trying to measure this diameter here somehow. This is wrong. We don't care about this diameter. What we care about is the distance between the bigger and the smaller cylinder. This is my tolerance zone. And the distance between these 2 cylinders is 0.1, and that's the value of the tolerance zone. So it's not a cylinder, it's a distance. All right, flatness. How do we add flatness to that surface? Let's do it here as well. So we point at the surface with an arrow, with a leader. We put our feature control frame of 2 blocks. In the first block, we add the symbol, which is flatness, and in the second block, we add the value, which is 0.1. Very easy. In that case, it would mean that we will have 2 flat surfaces. The distance between them is 0.1. And the real surface will have to fall between those. So in that case, these points here would be out of tolerance. All right. And then we will go about these 2 surfaces. Actually, this is the only view in which I see them. I also see them here in the dotted view, but I don't need that. I will just do it here on that view. So how do we do that? We point at the surface. We say it should be flat with a value of 0.1. And then let's have a look at this cylinder here. How do we tolerate it? Again, I will use the same view because that's the easiest one to use. So I would like to add some cylindricity. Point at the cylinder, not the center line, the cylinder, because that's the surface. that I would like to tolerate and say cylindricity 0.1. That's our exemplary value. All right, and then we would like to add the straightness of the center line. And here is where most people will make the mistake. How do you point at the center line to say, I would like this center line to be straight? You point at it like that. That's a mistake. You never point at the center line by pointing directly at it. Please remember this rule. Why is that? Because on the drawing, this hole and this hole have a common center line on the drawing because it's perfect as CAD model, and so they have a common center line. But in reality, this hole will look like that, or could look like that, and this hole could look something completely different like that. And in that case, they wouldn't have the same center line. So if you point directly at the center line, I wouldn't know which center line do you mean. Do you mean, if you point here at the center line, do you mean the center line of this hole, or do you mean the center line of that hole? There's no way to know, because in the drawing, they have the same center line. So the correct way to point at a center line is to point at the dimension of the feature that has the center line. So here, well, of course, in that case, I would like to control the straightness of the center line of both holes. So I would use the line that says 2 times. In case I want to control only one hole, then I will have to remove this 2 times and make a separate dimension for this hole than the other one. But let's leave it. So I have straightness tolerance that I would like to add, and then the value is 0.1, but it's a straightness of a center line, and we know that straightness of a center line means that the tolerance zone is a cylinder and the center line has to lie inside the cylinder, and the value of the tolerance zone is the diameter of that cylinder. So it is actually a diameter. I have to add a diameter sign to it. Okay. Yeah, that's it for that lecture. There are no profile tolerances to be considered here, but yeah, let's just, for example, if you would like to have this shape tolerated, we would say profile. Yeah, because it's not a line, it's not a cylinder, it's this shape, and we will put the feature control frame, sorry for that arrow, the feature control frame, and we would say profile was 0.1. Thank you and see you in the next exercise.